Hello mathematicians, it's Miss Armgart back with another instructional video. Today we are finding the prime factorization of different numbers. So first, let's review. What in the heck is factorization? Remember, factors are just whole numbers that multiply together to make the product. So for example, with 132, we're just going to do 11 times 12 is 132. 11 and 12 are factors of 132. Now, we can break that 12 down further because we know 12 is the same as 6 times 2, right? So we can now write this as 6 times 2 times 11 is 132. And then we can keep going because we know 6 can be broken down further. Now, 11 is what is known as prime number, which means the only factors of that number are 1 and itself. It can't be broken down further. You can't break 11 down into its smaller factors because 1 times 11 is the only thing. 2 is also a prime number. You can't break 2 down into anything else. So in this box are your prime numbers. So how in the heck do you use this to find prime factorization? Well, the box method, you draw a partial box around the number, and then on the outside, you write whatever you're going to divide it by. So 132 divided by 2, you write the product underneath. That is 66. Now, we look at these numbers. We check our prime number box. 2 is a prime number. So we're going to circle it to indicate it's done. We can't do anything else with it. We can't go any further. 66 is not a prime number, so we're going to draw another box. And we are going to divide by 2 again to get 33. Now, oh, look, we know 2 is a prime number, so we're going to circle that. 33 is not, so we're going to keep going. And 33 divided by, 3 is 11. Well, 3 is a prime number. 11 is also a prime number. Once all of the numbers are circled, you are done. You found the prime factorization. So we're going to write that on the line. It's 2 times 3 times 11 will give you 132. All of those are prime numbers. When you multiply them together, you get 132. Double check me on the math. Always, always. So now we are going to use the tree method, which will give us the same result, but it looks a little different. We're going to use 460 this time. So when I say tree, you draw 2 branches, and I'm going to do 10 times 46. So each of the lines across will give you the multiplication of the thing above it. So 10 times 46 is 460. Well, neither of those are prime, so I have to go further. We know 10 is 5 times 2. 5 and 2 are both primes. We're going to circle those. Now let's go over to 46. Not a prime, but 46 is 2 times 23. And both of those are prime numbers. Once all the numbers at the bottom are circled or factorized into prime numbers, here we go. So the prime factorization of 460 is 2 times 5 times 23. All of those are prime numbers. Now remember, if you're like, Armgart, what were the prime numbers again? Our list over here says 23. So then, why does this matter? Why are we talking about this? So what I want you to notice is that in any list of factors, these are all the factors of 132, we're going to get 2 numbers. So for example, 11 and 12, that multiply. We're also going to get 6 and 22, 4 and 33, and so on and so on. So we can list 6 times 22 is the exact same as 2 times 3 times 22, right? Because we know 6 is the same as 2 times 3, and 22 can be broken down. It's still 2 times 3 times 2 times 11. Oh, look, we got the same result as our prime factorization. So any pair of factors can be broken into the exact same prime factorization. So 132 will always have a prime factorization of 2 times 3 times 11. Doesn't matter what order you write it in. Doesn't matter which method you use, but 2 factors of a number will always give you the same prime factorization. Now, the cool math trick is you can actually use prime factorization to simplify really big fractions. So we've already found the prime factorization of 132. That is 2 times 3 times 11. We just proved we could do that multiple ways. We use the tree method for 460 to get 2 times 5 times 23. So now we are going to write this as a fraction. So if we're going to write the prime factorization of 132 on the top, and we're going to write the prime factorization of 460 on the bottom. Now remember, when we're doing division, we can break all of this out individually. So we know 2 divided by 2 will give you 1. Any number that appears in both the top, the dividend, and the bottom, the divisor, can be crossed out. So we get 3 times 11 and 5 times 23. There are no other numbers that are the same, so when we multiply those two together, we get the simplified fraction. In this case, 3 times 11 is 33. 5 times 23 is 115. So the simplified fraction for 132 divided by 46 is 33 divided by 115. So, of course, you could go and say, okay, divide the top one by 2, divide the bottom by 2. This is just a simpler, faster way to do that exact same thing with prime factorization. Now, as always, folks, there are vocabulary words. You need to write some examples. This paper goes into your journal. And until next time, happy solving.